Okay, so today we're going to talk a little bit about a couple of the technical committees that cover a lot of standards that look after mining. Not all the standards that affect mining, obviously. We've got a limited amount of time to cover them in, but EL14 looks after explosives atmospheres, and EL23 looks after most of the electrical mining equipment. But first we're going to talk about contributing to standards. So I'm going to start by just, the only question I'm going to ask you is, if you've ever been involved in a Standards Australia technical committee or a working group, either in the past or currently, I just ask you to put your hand up, just to get a sense of, you know, and also for everybody else to see the amount of people that are currently involved. Thanks. So what, about 10% of the people that are here, 10, 20%. So why would you get involved in Standards Australia? If you picture a typical situation, you're reviewing a standard and you're having a look at how that's going to apply to you on your site. Typical process is you work through the stuff that's easy to apply, the stuff that you understand, stuff that's fairly inexpensive to implement, and you maybe even get to some of the hard stuff, but you understand the reason why it's there. You don't really give a lot of thought to how those things made their way into the standard. But then you get to the bit that's hard to do, and you're not necessarily confident as to why it's there. You don't necessarily see the benefit. So I guess the message is that getting involved in standards development and making an impact on influencing those standards is within the reach of everybody in this room. If you made it to this conference, then you're definitely qualified to be involved in standards development. You've met those, you know, you've met the bar there. I've not come across in the mining environment an example of somebody putting their hand up to be involved in Standards Australia and being knocked back. It doesn't happen. Everybody that wants to get involved has an opportunity to be involved. Now, your involvement in that process can vary. The outcome you get from being involved can vary. There's a timeline that is worked to, so not every standard gets reviewed every year. You know, you may have to wait for that standard that you've got a problem with to come around for review. And then you're going to get one of three outcomes. Either people are going to listen to you, they're going to believe that your problem with that standard applies across the board, and there's a solution that needs to be implemented. Maybe that you're educated on why that's in there in the first place, and you change your view on the need for that requirement in the standard. It could be that you go away thinking, okay, I need to work on my skills of persuasion for next time because I still don't believe it, but they didn't listen to me. There's different involvements that you can have, but there is an opportunity to impact on the standards that you deal with on a day-to-day basis, and it's not difficult to get involved. Any of the people that put their hand up, if you recognise one of those people, will be your in to find out what the next stage is in getting involved with Standards Australia. Some of the other benefits, though, apart from the impact on you, are the networking. I mean, it's a great environment in which to meet a range of people, from regulators, manufacturers, testing houses, different end users from different industries. And it gives you an opportunity to talk to those people in a completely different environment to your normal interaction with them. You want to ask difficult questions, it's a great opportunity to do that. That you won't necessarily get in another environment. Which means that you're going to be exposed to some really smart people, and again, great for learning new skills. From a manufacturer's point of view, it can give you a competitive advantage. The other side of that is that it can stop you having a disadvantage. My personal involvement with Standards Australia began when I was at Fortress Resistors in the early 2000s. I got a phone call from Dallas Stokes, who at the time was the D in R&D technology. Many of you may know him. And he said, Phil, would you mind explaining to me why my customer had to tell me that AS2081 had changed before you did. And the neutral earthing resistors I'm selling him don't comply with the new standard. So for those of you that know Dallas will know that I've paraphrased him and removed all the swear words. Now, that, you know, my answer to that was that actually I didn't know it had changed, Dallas, so I couldn't have told you, and surprisingly that didn't satisfy him, so we had a lengthy conversation. And it ended up with me getting involved with the working group for AS2081, and then going on to become involved in the technical committee at EL23. So just being aware of what's changing within the industry is another really good advantage. It's also the pathway to involvement internationally, for example, through ISO or IEC standards. And then once you get at that point, it's going back to this list on a whole new level, but you've got global interaction with other countries and finding out how they operate, and different professionals from around the world, that you can really increase your learning. So from my perspective, I put a lot of time into standards development, and I've been lucky enough to work for companies that have been willing to pay for that, pay for the travel and pay for my time to be involved. But I definitely believe over the years I've got a huge amount out of the process. And in terms of who writes standards, standards are written by those that turn up. It's as simple as that. That's all you need to do to be involved in the process, and the rest happens. Diversity is a really critical part of standards development. And the reason for mentioning this is just to try to get people in the mindset that you can contribute regardless of your background. It needs a variety of different experiences to have a successful outcome when you're looking at reviewing a standard. The worst way to do it is to get 5 or 6 experts that have been in the industry for 40 years, get them to have a look at a standard and find out what needs to change, because they look at it, they know it all, they don't really need to read it, they've been doing it for years, they know what it says, but they know what it they really meant to say when they said that, and so they look at it and say it's fine. You bring in somebody less experienced who actually reads the document, and they go, you understand in the scope we said that this doesn't apply. Okay, you know, it prompts some really good conversations when you have a mix of experience in the room. It needs somebody to ask those questions that sometimes people are uncomfortable asking. The same with the roles that people play within the development process. You know, there are people who have skills in the technical side of it. There are people who understand the process that needs to be followed. There are people that understand what the end users do. There are people who understand how you manufacture products. And that all has to come through into the standards development process. So it doesn't matter what your current role is, what your history is, what your skills are. I can guarantee there's a role for you on a working group. And just quickly talking about different types of involvement. Technical committees are where we look at a lot of the strategic decisions. You represent somebody when you're on a technical committee. So in my case, it's AI group. It could be Engineers Australia, it could be MEMS. And in practice, you're representing their views. You report back to that organisation on what's happening. You vote on the approval of standards, and you organise which standards are going to be worked on and make sure there's working groups to do that work. And you also liaise with international organisations as well. You do need a nominating organisation, somebody to nominate you to that technical committee. And then there's where a lot of the practical work gets done, which is a working group. You work on the drafting of the standards. There'll normally be members of the technical committee on that standard as well, but you don't have to be a member. You don't have to have a nominating organisation. All you have to do is sign the Standards Australia committee deed. You don't get to vote on the standards, but you do get to develop the standards, and that's where most people start their work within Standards Australia. Literally all you need to do in that situation is get in contact with somebody that's already on one of those committees, get them to put you in touch with Standards Australia or the technical committee that are looking after those standards, and they'll drag you into the process. Okay, just a couple of, another way that you can contribute to standards development is through public comment. Standards Australia have implemented a new public comment process recently, which is online entirely. So the idea of submitting Excel or Word documents to them is gone now. You can try and QR code that to take you to the page where it explains how it works. You need a Standards Australia account. You do the review online, or you can download it and review it offline, but all of your commenting goes online. It gives you the facility to agree with other people's comments. You can't disagree with them, but you can put your own alternate comment in the same section. And in theory now, you get a feedback on what the result of your comment was. If Kent's in the room now, he'll tell you how much he's enjoying that process because he got 700 public comments from the recent 5368 public comment process and is in the process of trying to respond to all of that. So there's some work there that Standards Australia have got to do to manage situations like that. There's also a change coming through to how IEC documents are adopted within Australia. So there's a process now whereby instead of having an Appendix ZZ at the back of the document that was always really quite hard to read, that change is now potentially going to be listed within the standard itself. So you can see where the IEC document said something that is being varied, there'll be a box below it that then says this is how you apply it in Australia and New Zealand. Okay, so moving on to give you an update on what's happening within standards development. This is not meant to be a deep dive. This is meant to let you know that something has changed and give you an opportunity to go and look at what has changed in more detail yourself. We're going to talk about EL14, then go on to EL23, and there's going to be a little bit of talk about IEC because a lot of the EL14 work is based on IEC documents. Okay, so 60079 Part 0, which is the general requirements for explosive atmosphere equipment, that was amended in 2021. It was an administrative amendment to do with so Part 14 of that document, that series of documents, which is the design, selection, erection and initial inspection for explosive atmospheres. This is actually the first standard that included that national variation box. Because there were so many national variations in Australia, releasing it in this new version is going to make it a lot easier to read, because you'll have the change in the location in the standard where that change applies. This is an example of how the Australian adoptions can vary from IEC. In this case, we've got the current version of the IEC document has removed the requirements for reinstatement of cable jointing. And in the Australian adopted version, we've put that back in because we felt that it was inappropriate to take it out. In Australia, another example here is at IEC level, it doesn't cover mining, Group 1. In Australia, it does cover Group 1 requirements. So this document is a technical specification, which is like a mini version of a standard. And it covers explosive atmospheres for electrostatic hazards. Currently in Australia, those are covered by AS NZS 1020, and that document is being amended so that it doesn't cover explosive atmospheres anymore. It'll be everything else, and this new standard will apply in its place. So ISO IEC 80079 is the quality management system for explosive atmospheres, and this has gone through a minor change, but it does now align with this process and numbering within ISO 9001, which means that it's a lot easier to read and apply. So the 6007929 came out of the work that was done following the Pike River disaster, where there was established that the way that the gas detectors were actually operating was quite different to how we thought they were in practice, and there was some world-leading design work that went on within Australia. The work that came out of this is then being fed back up to IEC and has been applied at the IEC level as well. Unfortunately, there were some typos in this document, and so it's been amended to correct the test methodology that was in there. So the interaction between Australian standards and IEC, IEC Technical Committee 31 is mirrored by Australian standard EL14. So they look at, EL14 look at the standards that are released by TC31 and look at adopting them within Australia. They have recently revised 60079 Part 11. This caused a little bit of an issue within the ANZ EX scheme, because that scheme allows you to certify equipment to the current standard or the previous standard if that standard was released within the last 10 years. The previous version of this IEC standard is 12 or 13 years old, so the ANZ EX scheme have released a temporary notice for the next couple of years so that you can still certify equipment to the older version of Part 7911 or the current version. And just a bit of an update on what the committee are currently doing. So some of you will come across this issue of 6H, 8H fasteners and the difficulties that are happening during overhaul of equipment, where you're identifying that the whole thread tolerance has changed. Now, that's been addressed in a number of different ways. One of the ways is to look at modifying the current version of AS/NZS 60079 Part 1. This will include wording to allow the tolerance to drift from 6H to 8H during service, but the problem with this is it won't fix it for current equipment. This will only apply to equipment which is newly certified, and give manufacturers a route to include that provision within new certificates. So we'll come on a little bit later as to how else we're looking to address that same issue. But we are also working to have that wording put into the IEC documents, and Tim Webster, who's currently the chair of EL23, and Ian Webster, who's past chair of EL23, and both members of EL14 are currently in New York trying to influence IEC on that. So this is, so currently TC31 are looking at a couple of things at the moment. One of their subcommittees is looking at a version of Part 14, which is the electrical installations design and selection and erection. So a similar document for non-electrical requirements associated with that. And another different subcommittee, same standard, but looking at another version for Group 1 mining, which potentially is going to have some crossover with the new 5368. And lastly, they're also looking at revising the Part 0 general requirements of 60079. So Part 19, now this is an interesting one because this was actually developed from an Australian standard AS/NZS 3800 in the original, but IEC didn't adopt everything, so there's been a fight over the last 10, 15 years from a lot of people in Australia to gradually get them to include more of the critical information from 3800 into that standard. And so that's another round of work being done at the moment to look at revising that standard and to try to include more of those national variations that we keep including when that document gets adopted within Australia. And lastly, gas detectors. There's a project at the moment to pull together the different types of gas detectors that are used in mining into a single standard, which will make things a little bit simpler when we're adopting them within Australia. I keep saying lastly, but these are some more slides than I remember. So maintenance of, the 8079 Part 38 is not actually adopted within Australia, but that's something that we will look at once this new standard is released. So this is principally a mechanical standard, but will still have some relevance. So EL23 and EL14 work together on some standards as well. And coming back to this Part 19, this is the Australian adopted version of the IEC document I'm talking about now. This is currently a modified adoption. It includes a lot of national variations. So we're currently now working on a plan to bring that up to date with the very latest version of the IEC document and have it supersede 3800 altogether. So that will then become AS/NZS 60079 Part 19 instead of AS/NZS 3800, which will be withdrawn. We're at the point now where a lot of those national variations will be able to be removed, even though there are some that we're still working on with IEC. Okay, so moving on to EL23, which covers electrical equipment in mining, and the standards on cables, couplers and restrained sockets, 1299 and 1300 were really recently combined together under the name 1299. So we kept one of the names, one of the numbers, removed the other one. So that's basically bringing them together because they work on the same principle. We've released a revised version of 2290 in 2021. A lot of changes in here, so we're not going to go too deep on that, but some fairly significant changes in that standard. And 1747 is the other cable standard, and again, quite a large number of changes that were made to this standard. So looking at what we're currently working on at the moment, AS 2081 covers electrical protection devices. It's historically included quite a lot of application information in there. We're revising AS/NZS 5368 at the moment. Well, I shouldn't say revising. 5368 is combining AS/NZS 3007 with the 4871 series of standards. So that work is currently happening at the moment, and so we're moving the application related information that's in 2081 into 5368. We're also addressing issues around the use of VSDs in mining. So there's been a lot of work done to try to establish how we can design the relays to better operate in an environment where there are VSDs being used, which is a challenge that everybody's been facing for many years. And there are different ways that that's been addressed so far. We're trying to bring that into the standard. We're also looking at alternative ways that protection can be used, moving the document from being less prescriptive in terms of the relay has to do it this way in particular, more into a situation where it gives the manufacturers the parameters that they need to achieve and allows a little bit more flexibility as to how they design the relays to achieve those critical safety requirements. Looking at how you react to frequencies other than 50 hertz. Is it a real fault? Is it not a fault? Looking at the criteria that you would use to establish what frequencies need to be considered. And also considering that 5368 is going to be the application standard, allowing that standard to dictate what the settings should be, rather than saying in 2081 you have to set the relay to this range of standards. So 5368 is currently being edited again following a round of public comment. This is the one that we said we had 700 public comments, which is great, but that's a lot of work to do. It also leads through to a lot of changes following that public comment. And the process within Standards Australia is that if you make too many technical substantive changes to a document, it needs to go back out to public comment again. And so that's what will happen at some point. Maybe the end of this year, maybe early next year, be another round of public comment. And it's definitely something that all of you should have a look at, because it will affect everybody in this room in some way or other. So this is combining the 3007 standard, which in itself was 6 different standards until 2013, with the 4871 series of standards. So that you effectively end up with something akin to an AS3000 document for mining. So it's going to be an important document. I think that covers everything there. Another couple of standards that are planned to be merged are 1802 and 2802, again because the principles within them are very similar. And we looked at 2290 Part 1 earlier in terms of it was released in 2021. We're now looking at it again in terms of how we can look at addressing that 6H88 issue for existing equipment. So can we include a requirement in there that allows this to be dealt with in a way that industry are comfortable with for existing equipment rather than new certifications? Okay, Handbook 239, when ASNZS 60079 Part 19 is released, which will replace 3800, we're looking at replacing the handbook that goes with it with a supplementary to Part 19 on the overhaul of equipment. Now this really is, lastly, this is the work that's being done on battery-powered vehicles in underground coal mines. That project's been going for a couple of years now. There's been quite a lot of input from industry. It's about 95% complete, which will then mean it goes off to the editors and around a public comment next year, probably towards the end of next year. Looking at ways in general principles that can be applied to the use of battery-powered vehicles underground and the design of that equipment, which obviously is becoming relevant to a lot of different people. Not a lot of standards out there at the moment that cover the use of that equipment in underground coal mines. Plenty in open cut and metalliferous, but obviously the hazards in coal mines are slightly different. So this will be a fairly important document. All right, thanks everybody for listening.